3 lines of Python. This agent just planned its own research, wrote nodes to a virtual file system, and spawned a subagent to verify sources, all built in. You know that feeling. You build an agent, give it a complex task, and halfway through it just forgets what it was doing. The context window fills up with tool results, there's no plan and no structure. And if you wanted to delegate work to a specialized subagent, you're writing code orchestration yourself. Today we're fixing that with a single function call. So Deep Agents is basically an agent harness that sits on top of langgraph. It gives your agent 3 things out of the box. First, a planning tool called to write to-dos that forces the model to break tasks into steps before acting. Second, a virtual file system so the agent can write nodes, intermediate results, or anything instead of stuffing it all into the context window. And third, a task tool that spawns subagents with their own isolated context. Each one focuses on a specific subtask without polluting the main agent's memory. Here's the thing. This whole pattern was inspired by Claude code. Harrison Chase basically studied what makes Claude code work, extracted the core architecture, and made it model agnostic. And because create deep agent returns a compiled langgraph graph, you get streaming, checkpointing, and persistence for free. You don't lose any of the langgraph features you already know. Alright, you have seen the architecture, planning, file system, subagents. Now let's build a research agent that actually uses all 3. We'll start by creating a new Python virtual environment. And we have to also activate it. Let's also get the dependencies installed. We need 4 packages. Deep Agents is the harness. LangChain OpenAI pulls in the OpenAI provider. Tavily Python is our search tool, and Python.env lets us load API keys from a .env file so we don't hard code them. Next, let's create a 1.env file and put our environment variables here. We also create agent.py. This is the file where we will be working. First thing, we call load.env right at the top. That reads the .env file and puts your keys into the environment. Then we import create deep agent and set up Tavily client. After that we define a search function that the agent can call as a tool. Notice the type hints and the docstring. Deep agents use these to tell the model what the tool does and what arguments it accepts. Without them, the model won't know how to call it properly. The include raw content flag is important here. When it's true, Tavily returns the full page content and not just the snippets. That gives the agent way more context to work with. Now you write the system prompt. This is where you tell the agent what it is and how to behave. We're building a research agent, so we tell it to plan first, search thoroughly, and to write a polished report at the end. The key detail here is we're referencing built-in tools by name. The agent already has write to-dos, write file, and read file available. We don't need to create them. We just need to tell the agent when and how to use them in the prompt. So here's the thing. This is where it gets interesting. We're defining a subagent specifically for fact verification. The main agent does the research, but when it finds a claim that needs second check, it delegates to this subagent. Each subagent gets its own isolated context window, so all the search results and intermediate work from the verification don't pollute the main agent's memory. You define a subagent as a dictionary with a name, description, its own system prompt, and its own set of tools. The description matters a lot because that's what the main agent reads to decide when to delegate. And now we wire everything together. We pass the model, our search tool, the system prompt, and the subagent list. That's it. What create deep agent returns is a compiled langgraph graph, so you get streaming, checkpointing, and persistence for free. You don't lose any langgraph features you already know. And the planning tool, the file system, the subagent spawning, and all of this is already baked in. Raw streaming output from deep agents is a row of nested dicts and metadata. Not great for a demo, so we write a small helper function that pulls out just the useful stuff from each chunk. It checks whether the chunk is a tool call, a to-do update, a file write, or a final text response, and the namespace tells us if it's the main agent or a subagent talking. And now the actual run. We call stream with subgraphs equal true, so we can see inside the subagent's execution tool. Each chunk gets passed to our formatter. That's it. Let's fire it up. Alright, now let's open the terminal and run our agent.py file. Alright, now that it has done executing, let's see what happened. First, the agent identified 2 to-dos. First one is to conduct an internet search, and the second one is to compile the findings into a structured report. After that, it started executing it and switched the status from pending to in progress. After some time, it finished executing the conduct an internet search subtask, and later it also gave us the last output from the subagent. Alright, let's look at what you've got. You have a research agent that actually plans its work before jumping in. It writes intermediate results to files instead of cramming everything into the context window, so it doesn't lose track half the way through. And when a task needs specialized work, it spins up a subagent agent with its own isolated context. That is the same architecture powering Claude Code and Deep Research, and you built in basically 3 lines. From here, try dropping this into a langgraph project you already have. Swap the model out with init chat model, add your own custom tools, see how it handles your actual workflows. The whole thing is MIT licensed and provider agnostic, so you're not locked into anything. If you want more stuff like this, hit subscribe. I'll catch you in the next one.